In this scenario, we're looking at the average size of farms in two counties in Pennsylvania, Indiana County and Greene County. What they tell us is Indiana County, the average size is 191 acres. In Greene County, it's 199 acres. They give us the standard deviations from the sample. 38 for Indiana and 12 for Greene. And then they tell us we're looking at two very small samples here. Sample size of 8 for Indiana County and a sample size of 10 for Greene County. Since we're looking at small samples here and our standard deviations are coming from the sample, we know we're going to be doing a t-distribution or a t-test here. But we're still going to set up our null and alternative the same way. In this case, my mu1, my Indiana County, is equal to the mu2, the size of the farm in Greene County. And they're focusing on just the idea, is it different? So my alternate hypothesis, mu1 is not equal to mu2. Critical value, we have two-sided here. My degrees of freedom in this case, you have to look at your n of your 8 and your 10 and ask yourself which one's going to give me the smaller degrees of freedom. So my degrees of freedom ends up being 7. That's going to give me critical values of negative 2.36 and positive 2.36. I find my test statistic, which in this case is a t. Very similar to what I did if it was a large sample for my z-test. The only difference is now I'm basing everything off my sample deviations, the 38 and the 12. Again, be very careful putting this in your calculator. It's going to give you a negative 0.57 test statistic, which is clearly in my non-critical region. So we're going to fail to reject the null hypothesis. Since we're failing to reject the null, simple statement in this case, there's not enough information to conclude that there is a difference. Since we're keeping this, we're not rejecting the null hypothesis. mu1, the average farm size in Indiana County, mu2, the average farm size in Greene County, might very well be the exact same thing. There's not a significant difference.